remaining. Okay, last class we have done with the propeller. Main propeller is done. That was the major part. Okay, that is done. Tail propeller will be doing. Okay, so for this tail propeller, the principle or the procedure what we have followed for main propeller is completely same. The major difference is that the only difference is the dimension of this propeller and this propeller. That's it. Okay, geometrical parameters, okay, and geometrical dimensions are the major difference between this main propeller and tail propeller. Okay, I mean like main rotating blades and tail rotating blades of the helicopter. Okay, here we have our helicopter. No, this is our main, and this one is our tail rotor blades. Okay, so today we'll be doing this part. If time permits, then we'll go for skid. Okay, this one, that is what we have last part, landing skids. So let's go to sketch what we have. Okay, so this one is done in the last class. Main rotating blades of our helicopter we have done. So this is our tail component or tail rotor blades. Here we have two, so we'll add three. This one done, this one also done. So these are components we have done, right? Yes. So this is our today's designing part. I mean like today will be completing tail propeller. Part 7b, tail propeller. With respect to the tail propeller, what design parameters needed, that all I have mentioned clearly. Okay, with the calculation, what data we will get, or geometrical parameters or geometrical data. Okay, which is required to design tail propeller. That all data I have mentioned. So just we have to input our data in the open VSP, all these geometrical parameters which is required to design tail propeller in the open VSP, we will use all these geometrical parameters or our dimensions, tail dimensions, we will use in the open VSP. So we'll go to open VSP software. So here we have our software. Yeah, so what we have to do, we have to go to geometrical browser window. We have to select default propeller and we have to add. As we know that as soon as we add, we will get the propeller, and this propeller what we have, okay, all blades, this is completely default component or default part. Okay, for this we have to add our data. Okay, as per our requirement we will get the tail propeller. Okay, so the diameter 1.86. So just I will come to design and dia, how much, 1.86 meter. See, currently dia what we have for this default propeller, that is 30. Okay, you can observe now. I will change the view. Okay, so as soon as I add our data 1.86 meter, then you can able to see the changes. 1.86, enter. Yes, it got changed. I will fit on screen. Yes. Okay, this data has been done. We have inputted our value. This value input is done. I mean, like diameter has been added for this default propeller. Now number of blades 3. Okay, default we have 3. Let it be. No need to do any changes. Next, rotating angle between this blade and this blade, the rotating angle 20.72. 20.72. Enter. Right. Next, what we have? Yeah, beta 20. Beta value. It's plus 20. Okay, it's plus 20. So 20. Enter. Next, any other parameter mentioned? No, right? Directly you have to check root cap and tip cap. Root cap, that should be flat, and tip cap, that should be rounded type. So root cap flat, default we have flat, so let it be. No need to do any changes. Tip cap rounded. Okay, so as per our requirement, we have same root cap and tip cap, so no need to do any changes. Okay, no need to do any changes. Let it be. Now directly we will go to blades. Here, blade control points, we have totally 9 control points from 0 to 9. Okay, we have to maintain same. For this case, just use 0.27. Okay, from 0 to 9, what we have control points, maintain same control points, that is 0.27. 0.27. Enter. 0.27. Enter. So you can able to see the changes. Blade shape is getting changed. Okay, because I am maintaining same control points throughout from root to tip. Okay, 0.27. And yes, 0.27. Enter. So all 9 control points value has been added. Okay, so now next we can able to see the change in this graph, right? So that is respect to our blades. Okay, so to understand all these things, you must know the geometrical design concepts. Okay, theoretical concepts, geometrical design theoretical concepts with respect to the propeller. Okay, so we are dealing with the design, so that's why I'm just going with the designing part. So now next we will come to the section. How? Yeah, here I have mentioned totally 3 cross sections. So let's check default how many number of cross sections we have. 0, 1, 2. Only 2 cross sections are there. So let's insert one cross section between 1 and 2. Yes, yeah. So I have inserted one more cross section because as per our requirement we need totally 3 cross sections. That's why I have added, I mean I have inserted one more cross section between 1 and 2 cross section. between cross section 1 and cross section 2 I have added one more cross section. So let's check now. Yeah, 0, 1, 2, and last one tip side, that is 3 cross section, right? Now we will come to each and every cross section and just we will give our first radius value. If you input your first radius value in the sense, uh, let, let me first type, and after that I will tell about that. See, now currently you are here. Okay, from here to here, how much radius you want to maintain, that radius you have to input. So 0.0587, just mention this one. So even we have to change the cross section type. What cross section type I have given? Circular type of cross section. So let's change this ellipse type of cross section to circular type of cross section, and radius 0.05870. Just type that first radius value what I have mentioned, 0.05870, enter. Okay, so whatever you will get this value, let it be. This is default value. See, I have not typed anything, so the same value we have 0.05459. Okay, which means this one is enough. This radius, how much you want to maintain your radius from this point to this point. Okay, for that zeroth cross section, that is our radius value. Okay, so with respect to that you will get one more parameter, so no need to do anything to that, let it be. Next we will move to first cross section. First cross section details I mentioned here. First cross section's radius, which means this cross section, it is located from this centroid with a radius of 0.450. Okay, 0.450, 0.450, enter. Okay, yes, so this one, if you know, okay, then one more what will get opposite to that, so let it be, no need to do anything to that, that default will get. So that is what we have, see here, 0.41850, 0.41850, right? So it means only one radius is enough. Okay, this one, right? Because default we will get in the open VSP. Now cross section type, this type of cross section, NACA 5413, NACA 5413. So now currently the cross section type, it's a 16 series. We want 4 series, so let's select 4 series. Okay, and thickness to chord ratio and other parameter. Okay, 5413, 5413. So I'll change the combo location, that is 40%, 54 in the sense 40%, enter. 5413. Okay, yes, so which means here for the each and every cross section, just you have to calculate radius and your location of the camber. If you know these two parameters, this one and this one, so rest other things default you will get. So let it be 5413, that is what we got, cross section type. So that is what we have here, 5413. Okay, so next I will move now. Next, first cross section is done. Second cross section value, second cross section radius how much, 0.70. Okay, so 0.70, default we have that only, so I'll just maintain same 0.70, enter, and Just this one I have to change. Cross section type we need 4 series. Naka 4 series. Yeah. And thickness to chord ratio camber location, that is 540, which means location of the camber 40% from leading edge. So I'll change this location of camber location 40%, which means 0.4. Enter. Yeah. So we got 5404. That is our cross section type. Okay. 5408. You can even have a preview. Yes. Okay. Which means at this section, this type of cross section is exist. Now next, third one. So third radius is 1. So default you'll get that one only. Okay. See, default you got that one only, right? Because here we have mentioned overall dia. So for that case, at tip side from the centroid, overall radius automatically will get. Just we have to change the cross section type 16 series to 4 series. Okay. And camber location 40%, which means 0.4. Enter. Naka 2403. Naka 2403. Okay. Yes. Now, yes. See, initially it was a default propeller, so we have changed default propeller to our required propeller, which means we have done with our required part, that is tail propeller part is done. Okay. After giving our values, what we have design value. Okay. Which means you must know the geometrical parameters of your model, whether that is tail propeller, main propeller, wing, fuselage, any component. Okay. The 2D sketch is very important, and the dimensions and all other geometrical parameters what you are calculated for your design, that is very very important. Once you know all those in your hand, then just put or mention those values here in this tab, enter, and you will achieve your required component. So I'll share this now. Okay, so it's aluminum based, so I'll change the material. I will come to general. It's a default material. I'll change this default to aluminum. Yeah. And just to smooth the geometry, what I will do, I'll increase the number of tessellations. Number of tessellations I'll increase. Number of tessellations increasing in the sense number of wireframes I'm increasing just to smooth this geometry. Yes. Yeah. So this is our top view, front view. And left view, and our ISO view. Okay. So if you want only two propellers, okay, as per the design, purposely I've inserted one more propeller because for our this lane we have only uh, two, right? So purposely I've included one more. So you can change that one. Okay, just you have to come to design and you have to change number of blades 3 to 2 and enter. Okay, so it will not look that much good. So that's why one more I have added. That's it. Okay. If you are adding one more blade, in a sense, you are just increasing the performance. That's it. Okay. Yeah. So after completing this, just go to File and Save As. So file name tail propeller. Okay. Part 7B tail propeller. Part 7B tail just accept. You can go to file again, you can check your file part 7a, sorry, part 7b. Okay, yes, part 7b tail propeller.vsp, which means successfully we have saved our file. Okay, so we have done with our this one. So next we have part 8a. So before I go to this part A, I just want to check that time exists. Can I go for this case? I need 20 minutes minimum. Sir,
Yes, sir.
shall I proceed for this?
Yes, sir. Yes, sir. You can.
Okay, okay. So thank you for that. We have time, so we'll continue this also. See, landing skid. Under this landing skid, see, it's not only one part. I mean, like we'll differentiate our landing skid. Okay, this landing skid what we have, this one we'll call uh, part A. Okay, and this one part B, and horizontal one what we have, that one will call part C. Like that, you can call, and separately you can design in the open VSP, and you can assemble at the end. So today we'll complete this one, this part what we have. Okay, horizontally, which is lying on a ground, that part we will complete. So the dimensions and other parameters I have mentioned clearly. That is part 8a landing skid. Okay, so overall length 3.1 meter. Okay, and other dimensions I have mentioned. Just we have to go to open VSP. This is done now. So just go to file and new, because we are designing now new component. So that's why just go to file and select new option. So you'll get new window. Now to complete this part, landing skid A, landing skid bracket, I'll just make it A part, just to avoid the confusion. Okay. A part in the sense this one, which is horizontally lying on the ground. Okay, this one. Okay, like that we have no. So isometric view I mentioned here, and front view what we have, overall length 3.1 meter. Okay, long skid. Okay, for this part A, landing skid part A, even we will call it long skid length. Okay, or long skid length I have mentioned, that is 3.10 meter. So to complete this part in the open VSP, you can select your fuselage. By using this fuselage, we can achieve our landing skid. Okay, because as we know, fuselage is like also like a completely cylindrical object. So this is what we need. Okay, landing skid. Okay, this one we have to complete now. So this also like a tube, right? And this one also like a tube. So that's why we will use this component, fuselage default component, and by using this default fuselage component, we will achieve our landing skid or long landing skid. Okay, or long skid what we have, that one will complete. So that's why I'm selecting fuselage component. I have selected the fuselage component, and I have added here we have the default fuselage. Now what we'll do, we will change the length. So default length is 30 unit. So what we need for our case, that is 3.10 meter. That is our long skid length. This length 3.1 meter or 3.10 meter. Okay, so we'll input that value 3.1 meter. Yes. Mm, let's check the number of cross sections. Here I have mentioned totally 4 cross sections. Okay, 4 in the sense 0, 1, 2, 3, 4 like that. Now default, how many number of cross sections we have? 0, 1, 2, 3, 4. Okay, so here we have 4 cross sections. Okay, for this default component we have 4 cross sections. So let it be, no need to do any extra cross sections, I mean no need to insert any extra cross sections. So we will just now come to first cross, zeroth cross section, and we will input our value. So zeroth cross section length, how much? As we know, that is our starting point, so that's why that is like a 0 comma 0. So that's why we will maintain 0 default, that is 0 only, we know. And cross section type, yeah, it has to be closed, so that's why we have to select point. When we select point, then we can show that our geometry is closed. So that's why cross section type we have to maintain, that is 0 pointed type of cross sections. So that's why here we have default pointed type of cross sections. Suppose if I change this pointer to circle, and if I give any dia, so you can able to see it's completely open geometry, it's not closed. So to close this part, we have to select the point, and we can able to see, because of that point the geometry is completely closed. So now we will go to first cross section. Okay, first cross section. So here we have first cross section, and first cross section length, I mean like that cross section located 0.54755 meter away from this end. Okay, so let's change the view. Yeah, so this cross sections, first cross section what I have, that I have to place such a way that from nose this end, the length of that cross section where it is located, that is 0.54755 meter away from nose. Okay, okay, then we'll use 0. From here that cross section has to be located 0.54755. Enter. Okay, yes, this is done, no? Now next, cross section type. So which type of cross sections I mentioned? It's a circular type of cross section, circle type of cross section with dia 0.08 meter. Okay, so cross section type, circle type of cross section. No, see currently it's ellipse type of, we don't need ellipse type of cross sections, because see the shape is also like ellipse, you can observe. Okay, we have to change this shape ellipse to circle with dia. What is the dia? 0.08 meter. So we have to change this parameter 0.08. Enter. Next, this is done, no? Next, second cross section, same dia, same cross section type. The only difference is that that cross section that is located 1.55 meter away from this end. Okay, that cross section is located, which means yes, the second cross section, I'll jump to second cross section. So this cross section, yeah, see default we have the same length 1.55 meter. Okay, 1.55 meter, because we have given overall length, no? So a default cross section for that default model it was 4 only, so that's why automatically it's taking, OpenVSP automatically taking that second cross section length, that is 1.55 meter as per our requirement. Same we have 1.55 meter, only we have to change the cross section type. Okay, so cross section type, that is circular type of cross section we have to maintain. So what I will do, I'll change this default ellipse to circular type of cross section with same dia, that is 0.08. Enter. Okay, that is what we have now, 0.08. Yes, now we will come to third cross section. So I'll jump to third cross section. Okay, yeah, here is my third cross section, and yes, third cross section length 3.10 meter. So it's not 3.10, it's 2.3. So we'll change this to 3.10 meter. Yes. And cross section type, this type of cross section, it's a circular type of cross section with same layer. So we have to change this ellipse to circular type of cross section with same layer 0.08 meter. Okay, yes. Now, yeah, now we will go to this is done now. Yes, 3.10, 3.10. Yeah, we will come to fourth cross section. It's pointed type of cross section, and we can able to see default you'll get 3.10. So all input data I have mentioned clearly. Okay, now just we have to come to our view. I'll just change the view. I will use left view. Yeah. Yes. So jump to first cross section. Yes. So this one I'll just rotate. I mean like Z. Yes. So here we have the axis along Z. I will little bit bend it in a positive direction. I mean like upward direction. So that what I have to do. I have to come to general isolex form, rotate along Z. No, let it be 0. Okay, we will take symmetry of this and we'll maintain the distance. Yeah. Yes. Okay. So here, yeah. So overall distance between this to this 2.5 meter. That one you can keep, or else we have the geometrical parameter for that case. So let's change that x form 2.53. Yeah. Yes. So okay, I'll just maintain this all things 0. don't want to rotate, I'll just keep this as it is. Okay, so I'll just keep this model like this only. I'll just shade. Okay, when we'll assemble this one, that time we'll rotate this next component what we have now here. Yeah. So what I will do, this one I will call separately. Okay, so this is completely 3.1 meter. Okay, this one just will call this one separately. Okay, currently this one I have done now. So let it be this complete long skid. Okay, while doing this part, that time we will, yeah, while doing this part with respect to this, we have to manage its length and the distance. So that time I have to calculate for that now. So while going for this section, okay, next class I'll go for this section now. So I have to calculate the distance between this and this, and I have to manage the length properly. Okay, so that it should not get disturbed. So that's why that length measurement I will do, and I will update in the next class. That is what we have next part now. Okay, so we have done with our long skid. So just go to file and save this one and give this part name as long speed a long landing skid. Just I will tap long L, yes, long landing skid. Which part? Part A. Part A. Yeah, okay. So accept. Yes. So we have done with our long landing skid. So next class we go for our rest component what we have, and after that we'll go directly for assembly, because remaining part what we have, this one, okay, and this one measurement is needed, that one I have to mention, no? So next class I'll mention that, I'll calculate, and then we'll go for assembly. Okay, so I'll stop here. Thank you, thank you so much. Thank you, sir.
Okay, thank you, sir.